Hello all my JavaScript friends, this is the Virtuoid aka Mike Smith, and it's time for another Fun with JavaScript project. If you like this video, please click on the like button below, subscribe to this channel by clicking on the subscribe button, or leave a comment. I'd love to hear from you. So before I left on vacation this past summer, I was thinking back to my old Dungeons and Dragons days, and one of the very first computer programs I ever wrote was a dice rolling program. Now, within D&D, the dice rolling nomenclature usually is an equation like x, d, y, where x is the number of dice, d is dice, meaning you're rolling dice, and the y would be the side of the dice, or the sides of the dice. So, for example, if you're rolling 3 6-sided dice, the equation would be 3d6. Or if you're rolling a single 20-sided dice, it would be 1d20 or simply d20. The 1 would be assumed. And I thought, yeah, no, it'd be a lot of fun to redo that for Fun with JavaScript. But then I realized that's like maybe a 3-minute video. That's just not a whole lot there. But then I remembered that there's a lot of modifiers within the D&D game. For example, you may have a 3d6 plus 1. Or 2d20 minus 5 or something like that. So I thought, you know what might be more fun? Let's not just do the x, d, y. Let's do entire equations where we could say 3d6 plus 7 or 3d6 plus 7 times 4 or 7 plus 3d8 times parentheses 3 minus 4 blah 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 blah, on and so forth. So I thought, that'd be fun. Let's do an entire equation out of it. So this dice class that we're going to be working with is not only going to roll your dice for you, but you can also write entire equations. So what I'm going to show you is how you can write equations using a double stack method. Now this is the method that I learned many years ago, and it still works today. There might be better ones out there, but it's the one I'm used to. Basically, a double stack method is that as you parse the equation, you'll have one stack that represents the operators. That's the plus, the minus, the left parentheses, right parentheses, multiplication, division, all that kind of fun stuff. And the other one to represent the operands. That's like the numbers. So the idea here is that as you encounter a number or an operator, you take a look at the stacks, and then you grab data off of the stack, do the equation, whatever it happens to be, and then push that number back onto the stack. So for example, let's say we had 1 plus 2. Well, we found the number 1, so we push the number 1 to the operand stack. We have the plus, we push the plus to the operator stack. Then we have the number 2, that gets pushed to the operand stack. Now, that's the end of the equation. So once we get to the end, we then need to figure out, okay, we got to do the equation. So you pop your number off the operand, then pop the operator. The operator says it's a plus, so we're going to need another number. So we pop another operand, and we're going to multiply those two. Add those two together. So 1 plus 2 equals 3. That gets pushed back to the operand stack. Well, there's no more operators. There's only one operand, so our final answer is 3. And by doing things like that, you can get very complicated equations. And you can even do precedence. So for example, if you had 1 plus 2 times 3, now the answer is not 9. The answer actually is 7, because the 2 times 3 will be multiplied first, which gives 6, then the 1 plus 6. So we push the 1 to the operand stack. We push the plus to the operator stack. We push the number 2 to the operand stack. Then we push the multiplication to the operator stack. But we take a look at what's already on there. If we have a higher precedence, we just push it onto the stack. But if we have a lower precedence or the same precedence, then we do an equation. So the multiplication gets pushed to the operand stack. Then the number 3, the operator stack. Then number 3 goes to the operand stack. That's the end of the equation. We take an operand, take an operator, multiplication, so we need another operand. Take the other operand, that's 3 multiplied by 2, gives us 6. All right, that 6 gets pushed back to the operand stack. So we take that number, 6, we take the operator, which is plus, and that needs 2 numbers, so we need another operand. 6 plus 1 is equal to 7. That gets pushed back to the operand stack. That's the end of the equation. One value left in the operand stack, and we're done. So by having stacks, you are able to create some of the most complicated equations you can think of, as long as you take care of it. And so we're going to be doing a lot of testing with this project before we actually write the code. So that's going to be our next video. It will show you the test that we're going to use to be able to write our equation parser. And then eventually we might just go ahead and write a simple little calculator program later. But for right now, this is going to be an equation parser that's going to allow you to roll dice. Hey, make sure you click on the like button below and click on the subscribe button to subscribe to this channel. Also, please leave a comment. I would love to hear from you. Hey, thank you so very much for watching this video. Again, this is the Virtuoid, aka Mike Smith. We'll see you later.